Hi everybody, hope you're having a great day. Today we are going to start our discussion of probability. So before we jump fully into probability, there's a few things that um, we need to kind of review and learn. So probability by definition, and I made this is one of our um, cutouts that would be in or our notes that would be in our interactive notebook. I have blank copies online, and I will have this completed copy online as well for you guys to view. Okay, so by definition, the extent to which an event is likely to occur is probability. So what are the chances of it happening? Okay, you often hear it in when you're watching the weather. Oh, there's a 20% chance of snow today, although I think it's a 100% chance of snow or of rain today. You know, there's a 75% chance of wind. There's a, and that's what they're talking about. What is the probability? What is the likelihood that it'll occur? Okay. Probability is measured by the ratio of favorable cases to the total cases. Okay, and we'll talk a little bit more. Actually, we'll open it up right here and I'll show you an example of it. Okay, so here's an example. What is the probability that you will roll an odd number when rolling a standard dice? So I'm actually going to write out all of the possible outcomes. So we could have 1, 2, 3, 4, 5, and 6. Okay, so if I take a look at what are my odd numbers, my odd numbers are 1, 3, and 5. Okay, so we have how many odd numbers? We have 3 odd numbers out of how many total? 6. So our probability would be 3 out of 6. Now, we could also simplify this. Okay, 3 over 6, if we divide both top and bottom by 3, we are going to get 1/2. Okay, now, just like ratios, we can write it as a fraction. We can write it with a colon. We can write it in letters, okay, or in letters with 2. The other thing that we can do is we can write it as a percent. 1/2 is 50% chance. Okay, so you have a 50% chance of rolling a die and getting an odd number. Okay. One of the things that we could do to display our information is we could write a tree diagram. And think of a tree, think of the branches, how you have the trunk, and then the little branches kind of spread out from there. Okay, so a tree diagram is a diagram that shows the total amount of possible outcomes. Okay, and if we take a look at this, we have, you flip a coin and then you roll a die. What's the probability that you will land on tails and a 3? So when we do this, I like to use something called the counting principle. And basically what you're doing is you're multiplying the outcomes of how many outcomes there are for the coin, how many outcomes there are for the dice. So if we look, the coin has 2 outcomes. It could be either a heads or a tails. The die or the dice has 6 outcomes. 1, 2, 3, 4, 5, 6. So with the counting principle, what you do is you multiply those 2 possible outcomes. 2 times 6 is going to get us 12. So this tells us, oh, we froze. This tells us that we're going to have 6 possible outcomes or 6 branches at the end. So the first thing we're going to do is, what are the possibilities for a coin? Well, we could have a head or we could have a tail. Okay, so that is our first outcome. Now, off of each of those, off of the head, off of the tail, we are now going to have options for the dice. So if I roll a head, or excuse me, if I flip ahead, I could then have 1, 2, 3, 4, 5, or a 6 rolled. Okay, and you guys can kind of see how that there's a tree, the tree branches are kind of going. Then we could also, if I rolled a tail, and now I'm going to roll my dice, I could also have 1, 2, 3, 4, 5, and 6. Okay. So if we take a look and we have our tree diagram, we were looking for tails and 3. Okay. So tails 3, how many outcome? We have 1, a tail, 3. So we only have one path. And here, I'll show you what that. You here to here, and you have one path. So there's one favorable outcome over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12 different outcomes. So you have a 1 in 12 chance of rolling a tail, or flipping a tail, rolling a 3. So in probability, there's actually two types of probability. There's the theoretical, in theory, what should happen, and the experimental, what happens in an actual experiment. So we're going to talk a little bit more about these two. Okay, so a theoretical principle or probability is the number of favorable outcomes over the total number of outcomes. Okay, and this probability is based on what should happen. Okay, in other words, it's based on what should happen or is expected. Okay, so if we take a look, we'll close that. If we take a look, here's an example. What is the probability that the spinner will land on red? So if we take a look, remember we're going to have the favorable, so what we want, over the total number of outcomes. So we want red. So how many reds are there? Well, there's this one. There's one red out of how many total? 1, 2, 3, 4, 5. So there's one red out of 5. We could write that as a fraction. We could write that with a colon. We could write that in words. Or we could write that as a percent. And 1/5 is actually 20%. So we have a 20% chance of it happening. So now that's what we should get. 20% of the time that we spin the die or spin the spinner, we should get red. But that always doesn't happen. In experimental probability, we have the number of times the event occurred. Okay, did I spell occurred right? No, occurred. Okay, over the total number of trials. So the trials are actually doing the experiment. Okay, and this probability, experimental probability, is based on an actual experiment. Okay, or if we put it into other terms, it's based on what did happen. Okay, so let's just take a look really quick at these. So theoretical, in theory, what should happen or what we expect to happen. Experimental is based on an experiment or what actually did happen. Okay, so they're both two different types of probability. They work together, but they are separate. So in an experimental probability, I would normally have you guys actually, I have spinners, I would have you guys actually do the spinning and see what comes up. Well, because, you know, we've got other situation going on, I actually did the experiment myself and I rolled 20 times. Okay, so my spins, I rolled 20 times and I got 2 reds and 18 other colors. Okay, and this was when I did the experiment. This is what I got. Now I want to compare what I did get, my experimental probability, with my theoretical, with what I should have gotten or what I expected to get. Okay, if I take a look for my reds, I should have gotten 1/5. So I'm going to take a look here. I've got 1/5. Now, this is my theoretical probability, and my experimental, I had 20 total trials. So the 20 is going to go in the bottom. Just like we did in the rates and ratios proportional relationships unit, what's our jump? 5 to 20 times 4. We're going to do the same thing up here. 1 times 4 is 4. So I should have gotten 4 out of 20, but I actually did get 2 out of 20. So then I went a little bit further, and I kind of wanted to do a theoretical prediction of, well, what happens if I had my kids roll, I had my husband roll. We did 100 spins. Okay, so if I'm taking a look at our spins, so once again, I have 1/5. I should 1/5 of the time, or 20% of the time, we should get red. So we rolled 100 trials. Okay, so out of 100, this is the total of what you could get, total of the times you actually did the experiment. 5 to 100 times 20 times 20. I should get 20 reds. And when I actually did this experiment with the kids, with Mr. Sherman, I had 100 spins and I got 23 reds and 77. Okay. Now, if I were to take a look at this percent, the percent should be 20. If I take a look, I've had 2 out of 20 times 100. That was 10% for my own. When I did it with the kids and I did 100 spins, I got 23%. So basically the rule of thumb with experimental probability is the more trials, the closer the experimental probability will likely be to the theoretical. Okay, so more trials means experimental and theoretical are closer. Theoretical are more similar. Okay. All right. So I know this was a lot, guys. Try it out. I've got three problems for you on check-in, and we'll continue this. This is not, one and done. We'll do some more work with this and whatnot. See you guys later. Bye.